All right, so I've taken the electrode out of the pH 7 buffer, put the cap on it. Now I take the slot beaker, I give it a squirt like this, I squirt off the ATM, the temperature probe behind it, and then with this style electrode, notice this style has what are called beaker bumpers on them, where the pH sensing bulb is kind of protected a little bit by this plastic. So with this kind of buffer of electrode rather, I take it out of the holder and give it a little squirt of deionized water right up the throat, and then it's a good idea to just take it and give it just a little bit of a shake like that. Not anything huge, just to shake that little drop of water out of there. And then you go ahead and put it back in the holder just like that. Goes in very easy. And you take the next buffer, which will use a pH 9.18. Okay? So now I have the pH 9.18, and I lower the electrode and the temperature probe until you see that black, you see the black end of the electrode is well under the surface. But don't put it clear to the bottom, because there's a spin bar in the bottom of this bottle. And I'm going to turn the stirrer on, and you can't see it, but you may be able to hear it. Click, 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 click. Now this spin plate stirs too fast. So what I do is I put the buffer, the electrode in, and turn the stirrer on just a little bit, and then go ahead and turn it off. Now notice the display here with the basic buffer. Now again, this is the pH 9.18. The millivolt reading should be negative in the low hundreds. Now this hasn't stabilized yet. We don't see that read indicator right here yet, but we'll just give it a second. And again, for the sake of time, that hasn't changed very much, so I'm going to write down 9.18, which is the buffer, and then minus 114.5 millivolts. Now your numbers will be different, because you'll have different temperatures. Okay, once I've done that, I take it out of the pH 9.18 buffer, put the cap on, give it a rinse on the outside like this, take it, oops, don't do that, take it loose, give it a squirt down the throat, give it a little bit of a shake, set it back in there, and go to the acid buffer. This happens to be a pH 1.68. Okay, do the same thing. Lower it about halfway into the bottle, not all the way to the bottom. This one has a larger spin bar, so we may be able to leave it on. But you hear it clicking. Now it stabilizes relatively quickly when you're far away from pH 7. Now this is going to be a number that's high positive, and we'll give it just a second. Again, you would wait until you see the read indicator come on about right here in this part of the scale. But again, for the sake of time, 1.68, and this, I'll write down 2.286.0. There's no decimal point in this one. It's there, it says ready. 286 millivolts, 286 positive. Okay? Now you take the electrode out. Give it a squirt. A little shake. And now we are ready. Just put it back in there. And now what you would do is you would take your reading and run the linear regression with the pH values of the buffers as the X and the millivolts as the Y. And if you refer to your protocol where I have the sample standard curve, you should get a curve that looks like something like this, where this is millivolts and this is pH, and here's your 2 buffer and your 7 or your 7 and your 9.18, and this 2 is really 1.68, and you should get a dead straight line like that, where your points, I'm sorry, no point there, are in a virtual straight line with a slope of about minus, last time I checked it was like minus 53 millivolts per pH. Now it'll be slightly different, and there'll be a decimal part of that number. But if you get a correlation coefficient of virtually 1, minus 0.999, and a slope of around minus 53, then you are in business, okay? Now that ends the calibration. Now you'll go to the alkalinity determination. Notice I've left the electrode just hanging in the air, okay? And it'll stay that way until we put it in the seawater. All right, so in this one.